So let's set up this kind of equation. This equation has a name. It's called a perfectly inelastic collision. That doesn't mean something dirty in French, does it? I didn't look it up. It does? Okay, good. Perfectly inelastic collision. So why it's called perfectly inelastic collision will be clear when we get to energy. I'm sorry, not next week, in 2 weeks, when we get to energy. So elastic means it conserves energy. Inelastic means it loses energy. Perfectly inelastic means it really loses energy. It loses the most energy you can possibly lose and still obey the laws of physics. Okay? So it kind of looks like this. We have the mass M1, V1I, and we have the bar M2. Oh, I'm on the wrong page. Okay, here we go. I'm just an actor. I don't actually know what I'm doing. And we have the mass M2 going this way, V2I. Here we go. All right. So we just have to conserve momentum. So once they come together, then it's going to be one object, M1 plus M1, M2. And they're going to move. V final. We can just call it V final. Okay. Let's see. Yes, what is T2, OE2, and UAO? Okay, don't worry about it. Okay. It's 2 equations, 2 unknowns, 1 equation, 2 unknowns, and 1 equation, 1 unknown. It's not important. It's just what keeps us all awake, or an attempt. Okay, so let's look at initial momentum equals final momentum. Okay, initial momentum. Now, oh, this is important. Okay. Oh, my God. Okay, when you just look at this, do you know which way it's really going to go for VF? You don't really know, do you? Right? It could be that this one is really heavy and really fast, and it's just going to barrel through that one, and it's going to go this way. Or it could be this one is really fast, but this one is really heavy, and it's kind of fast, and the whole thing's going to barrel this way. So when we do these equations, we don't know V directions. Usually, V direction, so use components. Okay, we're not going to do it with magnitudes. We're not going to insert the signs, because these collision problems are usually much more unknown. When we were shooting the shotgun, I knew we were going to go back. I knew the bullet's going to go forward. We put in the negative sign, but we're not going to do that now. So we're just going to say M1 times V1 is the initial. I guess we can say initial. That's its initial momentum, plus M2 times V2I. Right? Now you say, that's crazy because I drew it this way, but this could be a negative number because it's just the component of a vector. Okay? We could put the vector hat on it, but it's 1D. Okay? And also, it doesn't have to go this way. Could they still hit if it was like this? Yeah, if this one's going faster, it'll eventually hit that one. Right? So they don't have to be coming at each other. So even on the initial case, you don't necessarily know which one is positive and negative because we're trying to write this for any situation. That has to equal, what's the momentum final? M1 plus M2. And then V final. 1 equation, 1 unknown. Yeah. So we solve it, and we get VF equals M1 V1I plus M2 V2I over M1 plus M2. Okay? And that's the answer.